Hello students, today we will learn about this dielectric strength of a dielectric. You know very well what is meant by a dielectric. Glass, ebonite, mica, these are all the examples of dielectric. A dielectric is nothing but basically it is an insulator. That is, it is a non-conducting material which doesn't contain any free electrons. That is, if you take the atom of a dielectric, these electrons, these free electrons are bound to the nucleus. They cannot come outside the nucleus. They cannot come outside the atom. They are bound to the nucleus. So, there is no possibility for current conduction of charges. But when this dielectric material is kept in an electrical field, what will happen? The external electric field will modify the alignment of the charges. That we are going to see how it is going to align the charges. Before going to this, we will go for a conductor. Listen children, I am going to have a positive plate and I am having a negative plate. What happens? There is an electrical field, capital E. Example. This electrical field is existing. I will assume the value as 1000 volt meter power minus 1. The unit of electric field is volt meter power minus 1. So this value is 1000 volt meter power minus 1. When a conductor is placed, a metal plate or any metal surface is placed in this between this in this electrical field, what will happen? This electrical field, what it will do? It will make the electrons to move towards the positive side of the electric field. And the positive charges are aligned towards the negative side of the electric field. So what happens? In the side positive charges irukudhu, in the side negative charge irukna, appa inga or field irukuma. That field I will call it as internal electric field. The value of the internal electric field will be how much means same. Idu evlo electric field evlo irundho adhe alavu da inge irukum. 1000 volt meter power minus 1. Is it clear? So that is the property of a conductor. When a conductor is placed in an electrical field, the charges are moving such that an internal electric field is produced, which is equal and opposite to the applied electric field. Now, kudutha field ku equal avarkum opposite avarkum. Appa what is the net field? Net evlo field irukum parunga, E plus E external field, idu internal field, rendume equal in magnitude parunga. Appa what happens to the internal field? It is zero. Even though a metal plate, a conductor is placed in an electrical field, the electrical field inside the conductor is 0, E equal to 0. But this will not happen in case of a dielectric. You can see the dielectric. A dielectric nothing but a glass slab. This glass slab is placed in an electrical field. This the electrical field. The character. Imagine this is the electrical field, external electric field. The external electric field, it is not making the electrons to move. But what it is doing, it is aligning the electrons. Electrons are aligned towards the negative side. Electrons are negative side applying. Positive charges are applying towards the negative side. Electrons are aligned towards the positive side. Positive charges are aligned positive negative side. Stop. So, what happens? The external electric field does not make the electrons to move, but it is aligning the charges. So, in the mayorno, it is rotating. I will have it like this. So, up positive, negative ka, up in your field room, up positive charge, negative charge, positive charge, negative charge. So here I have a small electric field, positive charge, negative charge. Here I have a small electric field like this. What will happen? If I add this small electric field, I get a small internal electric field inside the glass, that is inside the dielectric. Your main field, look at the magnitude on our size of our magnitude is very large, 1000 volt meter power minus 1. Look at the value of the internal field, it's very less. I will assume it is 50 volt meter power minus 1. So, now put the field 1000 volt meter power minus 1. Apply adanaala charges align aagudhu. Due to the alignment of the charges, the electric field is produced. That electric field is 50 volt meter power minus 1. Appa definitely net field irukuma? Definitely there will be an electric field. How much is the net field? Net evlo field irukum solunga paapom. Net field 1000 volt ipdi act pannudhu. Internal field is acting in this direction. Appa subtract pannumna for example solren 950 volt meter power minus 1. Appa when you place a dielectric in an electric field, dielectric kondu poi electric field vechingna, appa dielectric ulla net field irukuma? Definitely irukum. How much? 950 volt meter power minus 1. It is an example only. So net field will be the difference between the external electric field and the internal electric field. Is it clear, children? Suppose if you want to define what is meant by dielectric constant, the dielectric constant நம்ம ஏற்கனவே படிச்சிருக்கோம்ல epsilon r னு. Dielectric constant என்ன தெரியுங்களா? ஒன்னும் சிம்பிள். நான் கொடுத்த field external field by net field. The ratio between the external field to the net field is known as dielectric constant epsilon r. இப்போ எவ்வளவு வரும் பாருங்க. நான் கொடுத்த field எவ்வளவு? ஓகே. Suppose இதை நம்ம பார்த்துட்டோம். அதை நெட் ஃபீல்ட் தான் பார்த்தோம் இல்லையா? 1000லேருந்து ஒரு 50 சப்ராக்ட் பண்ணால் அப்போ நெட் ஃபீல்ட் பாருங்க ரொம்ப கம்மியாக இருக்காது, சின்ன சைஸாக இருக்காது. அப்போ இட் இஸ் 950 volt meter power minus 1. Is it clear? Suppose if the value of this, I will stop this. If the value of the net field, suppose if the applied field is very very large, the applied field is very very large, என்ன ஆகும்னா this applied field பாருங்க ரொம்ப ஹெவியான எலக்ட்ரிக் ஃபீல்ட். Suppose எவ்வளோ பாருங்க, in case of glass it is 14 into 10 power 6 volt meter power minus 1. When you apply this much amount of charge, what will happen? When you apply this much of electric field, what happens? This electrical field, what it will do? It will tear the atoms. Atoms are tear பண்ணி, it will make the electrons to move. It will make the charges to move. Is it clear? So you can see electrons are moving, isn't it? So this in the electrical field வந்த உடனே இந்த dielectric என்ன மாறிடுது? It is getting converted into an conductor. The value of the electrical field in which the dielectric is getting converted into a conductor is called as dielectric strength. Is it clear, children? So I'll stop. So what is meant by dielectric strength? The maximum electric field that a dielectric can withstand before it breaks down. Before it breaks down, it is getting converted into a conductor. கண்டக்டரா மாறுற வரைக்கும் அது அந்த எலக்ட்ரிக்கா இருக்கிற வரைக்கும் அது அது அந்த ஃபீல்டு வந்து டயலக்ட்ரிக் ஸ்ட்ரென்த் கிடையாது. எந்த ஃபீல்டு நீங்க கொடுத்த உடனே, எந்த ஃபீல்டு பாருங்க வேல்யூ ரொம்ப லார்ஜ், எந்த ஃபீல்டு நீங்க கொடுத்த உடனே அந்த டயலக்ட்ரிக் பிரேக் ஆகி எலக்ட்ரான்ஸ் பிரேக் ஆகி சார்ஜ் கண்டக்ஷன் எலக்ட்ரான்ஸ் கண்டக்ஷன் ஆஃப் எலக்ட்ரான்ஸ் நடக்குதோ தட் ஃபீல்டு மேக்ஸிமம் எலக்ட்ரிக் ஃபீல்டு is called as dielectric strength. Is it clear, children? So in our book they are given for various dielectric material they are giving what is the dielectric strength. For air பாத்தீங்கன்னா 3 into 10 power 6 volt meter per minute கொடுத்தீங்கன்னா air becomes a conductor. airல charge electrons வந்து மூவ் ஆகும். So it's a 2 mark question, ஒரே 2 mark question வர வாய்ப்பு இருக்கு. Dielectric strength, what is the dielectric strength? The maximum electric field a dielectric can withstand till it breaks down. That is till it breaks down, it is getting converted into a conductor. That the field is called as dielectric strength. Is it clear, children? So thanks for watching, children. Thank you.